And this isn't even clickbait. I genuinely think this is the easiest way. Um, I mean, hi and welcome. Since I started working with Unity, I've been using the new input system, and it sure feels like there are about a dozen different ways to make it work. I think I worked with at least 7 or 8 different kinds of systems over the years, but none stuck. Until I started using this input relay system. I've been using it for a bit over a year at this point. It is a central scriptable object you'll reference on any script that needs to react to input in some kind of way. The neat part is that it makes enabling and disabling certain input super easy, like disabling world input while your player sits in pause menu, for example. You'll write this once and take it with you from project to project. So yes, there is a tiny bit of added workload now, but I promise it is very, very small. So let's get started with the input asset itself. Feel free to use any input asset you already created previously. I'll just be using the one I've been dragging along for a while, but if you don't already have an input asset, it is easy to create a default one with lots of useful basic functionality already added in. Add a new object to your scene and add the player input component to it. If there is an input asset anywhere it can find, you'll see it referenced at the top field. If it stays empty, or you delete that reference, you'll get a button to generate a new one with all the default values. You can then remove the object from your scene again. Sometimes packages come with their own input assets, which is why I rename mine to Game Input. Click on it and in the inspector, checkmark Generate C# class. That's all the setup required. Let's head to Writer to write some code. I'll give you some examples for how to use this once the script has been written. This system has a single class at its heart, the input relay. It is a scriptable object and uses the GameInput.iPlayerActions interface. That one was created just a step before when you generated the C# class. You can actually find it if you open the class and scroll all the way to the bottom of the script and then up again since you landed in the UI section this way. This interface has knowledge about all the kinds of input you have set up in your asset, and when you remove one or create a new one, it will automatically be changed and updated. By using this interface in our relay, we make sure that it will always match what our input asset requires. You should already see it sporting a red line, prompting you to include all the necessary method it requires. Right-click on it and add them now. As you can see, their names match the input actions, just with an added on in front of them. I don't add the UI actions interface to this script because I typically don't need to customize anything there. It is handled well by the event system without me needing to rewrite anything. However, if your game requires it, of course add it just like you did with the player actions. Having calmed down our shouty script, let's step back and add some useful utility at the top before we'll jump into the actual methods. References, events, and of course the functionality to enable and or disable whole groups of input actions at once. It starts with a reference to the game input. That is what everything will use to hook up functionality. It is primarily useful for everything you need to check constantly, like the position of a mouse or whatever's happening with the player's scroll wheel. We'll ignore the rebinds for now. That's the topic of the next tutorial. At least if this one's being clicked and liked enough that I feel people would be interested in it. Please let me know if you'd like to see that. The next block is all about enabling and disabling input. First, we start with ensure game input was created, which creates a new one in case we don't yet have one. The setCallbacks line registers this object as the receiver for the player's web action events. That way, all the methods you added via the interface are then correctly linked up to the input. All that's done, come the few short methods that enable and disable input as requested. Enable all, enable world input, that's just what I call the actions performed in the world, like interacting with a box or moving. Enable UI input, and the two disablers. While I disable all player actions here, I do manually enable the one for pausing again. If you forget about this while copying, you won't be able to escape out of a pause. Once we are done with the script, I'll show how these can be used to disable world input during pausing. This input relay has two types of modes it supports: notifying about player input via event or offering constantly tracked input. For the first group, we'll add some event actions other scripts can subscribe to. I am a tad bit grumpy that the methods are already called onMove and such, because that's typically how I name my events, so these get the past tense: onMoved, onLooked, and so on. Moved and looked get a vector2 action, because that is the value the input system is set up for. You can check for that by looking at the right box for each input action. Whatever you need to notify about, just add the same type of value action it hands you here. Which is a rule I will now break for the next two. OnPanned is for panning the camera. If you played the early version of Hide and Sheep, you might have noticed that the camera only moved while you pressed down on the middle mouse button. I still don't know what made me code it that way, honestly, and it has been patched ever since, by the way. However, this react to if some button is pressed or not is a bool I can check for, so it got added. On zoom, however, is a vector2, but tell me just one instance where you actually needed the horizontal scroll value. Sure, maybe if it is a trackball, I guess, but the y value is all I need, so I'll just discard the x value. All the others are just the reactions to specific buttons being clicked. These are the one-offs, so the constantly checked values follow. These read a bit more complex, and just in case you're not yet familiar with the right arrow, it is essentially a short form of handling very short methods to save a bit of space. Each entry reads the value, which is what you'll typically use when you are working with anything but a button. Maybe don't use them for single checks like the actions above. I use these typically as some form of values that will constantly change, like the direction a player walks in. You can also add the constant check for buttons being held down if needed. You can use isPressed instead of the read value. In some cases, it is more intuitive to work with the event being triggered, while at other times it makes more sense to just check it this way. It always depends on what you want to do, like if something should happen on the press of a button, or if it is just being used as some form of modifier that doesn't require any further fanfare. You might have spotted that I track my mouse position with the UI map. This came to be when I tested with cutscenes and the likes, and did not want the player's mouse to react to any input, on top of disabling world input. By disabling the UI map as well, I got that under control much more reliably than polling for the mouse current position all the time. This being done, we head into the methods we created at the start. These will be called when their corresponding input is being performed in some kind of way. I say in some way because you have a few different modes, called phases, to pick from. First, you get read value again. To be honest, I hardly use these three events because it is simpler to use the constantly polled ones. But as mentioned, there might be good reasons to check if any of their values changed at any given point, for example to trigger some pop-ups or effects or debugging. On zoom is a bit of the odd one out here. It first checks for the context phase, so will only fire if the mouse wheel has actually moved, instead of constantly checking its y-axis. Performed phases are the ones that tell an interaction has been completed, which is a bit different from the ones you'll see next, as this can take wait times into account, like holding a button down for a second to unlock something. Then there are the more interesting ones. OnPan is my modifier for panning the camera while a button is being held down. This means it has two phases: a started one, when I start pressing the button, and a cancelled one. Naming threw me off here at first. Cancelled just means that your player has stopped their input and released the button again. Started is the moment the button goes down, on the other hand. OnPanned is an event that takes a bool, so we can relay both phases easily. All the other events are simply checking for the performed phase and invoke their corresponding events when called upon. Enjoyed the video this far? Please give it a like and consider subscribing. I love creating tutorials, and you'll find many more on my channel. So let's see how to work with this one in action. Create an input relay scriptable object now. I have two scripts I want to show, each one using the relay in some form. Please be aware that these are really just for explaining how the input relay works. They are not meant as battle-tested movement or camera control systems. Before I can show them, however, we need to write one short additional but load-bearing script, or our console will shout at us. This is my small input handler and takes a reference to the relay, tracks if the game is currently paused, as well as an event to invoke in case the player pauses. I have a small UI element that listens for that event and displays the pause indicator in that case. In awake and destroy, I subscribe and unsubscribe to the pause event, and in start, it just enables all input. The toggle invokes the event and disables word input in case the player entered the pause menu, and vice versa on their way back into the game. Add that one to your scene and your input will reliably work. The first two use cases are inside the player mover. It moves the player, well, in the direction of the player's input. To do so, it grabs the constantly updated current direction from the relay during update and uses it in the way it calculates how and where to rotate and move the character. To be able to interact with things, it subscribes to the onInteracted event with the handleInteract methods. Only when the player presses the corresponding key will this method be called upon. This is what the complete script looks like, and again, this is not an example of a good movement script, just one that shows how to use the relay's notification and constant polling system. The other script is the camera mover, which has a bit of an odd ability just for demonstration purposes. In most cases, it is just a third-person camera the player can rotate by moving the mouse. That is built around the look value that is constantly tracked in the relay. However, if the player holds down the key I assigned to panning, the camera leaves its initial place and pans in the direction the player moves their input. Nonsensical as that might be in most cases, but it serves its purpose to explain how the system works. This is possible since it checks the constantly checked isPanPressed value. To make it more visible when a change happens, I also added a method that writes to the console if the key is held or released. If you're not fond of using a constantly checked value for something like this, which only might change every once in a while, you can just use the event to switch a value in the script instead, and then check for that one. And once more, here's the complete version with the caveat that it is really just for demonstration purposes. Do not use this in anything your heart is attached to. Good so far? I have two very small additions to round the system off. First, this is a small script I add to all my scenes that will check if the cursor is currently over the UI. By having one thing constantly check for it, I can have every other class use their findings when determining if some input is actually supposed to happen or not. You can't add the over UI check to your event-based methods because it would look at the same frame as your input, and somehow that doesn't fly. By throwing it into the update and storing it in a value, the event-based methods have an up-to-date, reliable value to work with. By having just one script constantly check, you also won't have to add an update method to all the scripts that need to check for UI hovering either. Here, for example, I have a UI panel in the bottom right, and neither panning nor interaction works while my mouse is over that area. Second, if you subscribe or unsubscribe to the relay events, you'll currently get a long list of methods you could potentially subscribe to. I used quotation marks here. Outside of the relay's functionality, there won't ever be a moment where you'll have to call those from outside. But since they have to be public, they will clutter up your context menu. To get rid of it, add gameinput.iPlayerActions to those methods. This way, the methods get hidden behind the interface, which you typically won't access from an input-reliant script apart from this relay. Once you have all of this done, select the input actions, the generated class, and the three scripts we wrote in this tutorial, right-click on them, and export them as a Unity package. Uncheck both boxes at the bottom to really only get the selection, and save it to a folder you'll remember to look into. From now on, you can simply drag it into any new project and have a point to start from. If you ever need to make changes to your interactions, like removing entries or adding new ones, you can, of course, just do so. The input relay will then throw an error that not all methods have been implemented. So open it again, right-click on the interface at the top, and add the missing methods. Methods that aren't any longer in use will be grayed out and you can remove them. I hope you enjoyed this one. Really, it primarily came to be because somebody in my community mentioned he was too lazy to use the new input system, and if there's something that triggers my inner teacher like nothing else, it's people calling themselves lazy for small stuff like this. Also, I recently reworked my whole private toolbox, which included a keybind change system, which I wanted to show off. But that really only makes sense if I first show how I work with the input system in the first place, really. Anyway, if you enjoyed this video, please give it a like and consider subscribing. Thank you for watching. Have a great week.